Have you ever wondered why the moon orbits the Earth, or why an apple always falls down and not up? These everyday occurrences, from the simple act of walking to the complex ballet of planets, are all orchestrated by a single, powerful influence. Gravity is considered a fundamental force because it is one of the four basic interactions that govern everything in our universe, acting between any two objects that have mass or energy. Unlike other forces that might operate only in specific situations, gravity is universally present and shapes the cosmos on the largest scales, determining the structure of galaxies, stars, and planets. The fundamental nature of gravity stems from its relationship with mass and distance, a concept first elegantly described by Isaac Newton and later profoundly redefined by Albert Einstein's theory of general relativity. Newton's law of universal gravitation told us that every particle attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Einstein took this further, proposing that gravity is not a force pulling objects together, but rather a curvature of spacetime caused by mass and energy. Objects simply follow the shortest path through this curved spacetime, which we perceive as attraction. Understanding gravity as a fundamental force helps us grasp why certain rules of physics apply everywhere, from the smallest particles to the largest celestial bodies. You can observe its effects directly by noticing how objects accelerate towards the Earth when dropped, or indirectly by observing the tides, which are caused by the gravitational pull of the moon and the sun. This knowledge allows scientists to predict the orbits of satellites, design spacecraft, and even detect distant exoplanets by observing their stars' tiny gravitational wobbles. What makes gravity truly unique among the fundamental forces is its range and its universal attractivity. While the strong and weak nuclear forces operate only over incredibly tiny subatomic distances, and electromagnetism can both attract and repel, gravity always attracts and has an infinite range, albeit diminishing with distance. Physicists continue to explore a quantum theory of gravity, seeking to reconcile it with the other three fundamental forces in a unified framework, perhaps through hypothetical particles called gravitons. Ultimately, gravity is not just a force that keeps your feet on the ground. It is the cosmic architect, the sculptor of stars and galaxies, and the invisible hand that binds the universe together. Recognizing it as a fundamental force underscores its inescapable presence and its critical role in everything we observe and experience, making it a cornerstone of our understanding of reality itself.